Welcome back to another LeetCode problem. This time we're dealing with an easy one. LeetCode number 21, merge two sorted lists. So we're giving the heads of two sorted linked lists, list 1 and list 2, and we're supposed to merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So splicing together means we are not going to create new nodes, right? And we have some information here. So the number of nodes is limited, but there could be 0 nodes in any of the two lists. So that's going to be an edge case that we need to take care of. The nodes have some values. Well, we don't really care what they are. Just need to be able to compare them. And both lists are sorted in non-decreasing order. So there could be repeating elements in the list, but other than that, they would never be in decreasing order. Okay. Cool. So let's look at this example. We have two lists. So we're going to pick, I guess, one of the two ones. I don't think it matters which one. And then the next value would be 2, 3, and then one of the 4s. So that in the end we have a sorted linked list that is all the nodes merged. And I guess the order of them doesn't matter. Into one sorted list. Yeah, it doesn't tell us whether we should prefer nodes from list 1 or list 2 at all. Right, here we take this from list 2, and then we take 2 from list 1. Then we again from list 2. List 1, now list 1 is preferred. Yeah, so I guess that's going to be a linear time operation in the length of the two lists. And we're not going to use any extra space simply because we're going to reuse the nodes, and we're just going to change the next pointers to keep the space complexity constant. N plus m space and O of 1. What am I talking about? So n plus m time and O of 1 space. N is length of list 1. M is length of list 2. So yeah, I guess we need we need to return a head, right? Return head, but in the beginning we don't know what the head is going to be. Okay, cool. And we're going to use an iterative approach as well. Otherwise, if we use recursion, we're going to have a space complexity that is dependent on how many recursive calls we'll have. So while I guess list 1 or list 2. So that means while we still have any nodes in any of the two lists that are not processed, we're going to continue. So if list 1 and list 2, so I guess that's one case where we have nodes in both lists. Else, if list 1, else, well, the last case is if list 2, and the third case should never happen, right? Otherwise we wouldn't be in the while loop. So if we only have elements in the list 1, I think that's the easiest one. And well, we need something to point at the current tail node of our list that we're building. So we're just going to do this. We say head equals tail equals none. We don't know what it is. Right. Yes. So, well, in the case that we have list 1 and list 2, we need to pick the smaller one, right? If list 1 dot val, that thing, is smaller or equal list 2 dot val, then we're going to pick next would be list 1. And maybe we should do it like this. We'll just pick the next node to choose from will be is list 1. And we say list 1 is list 1 dot next. We advance this one more. Else, what we'll do is we'll say the next is list 2. And we're going to advance the pointer of list 2 for the next iteration. And same here. So if we only have elements in list 1, that means we're going to advance the pointer in list 1, and we're going to choose the current head of list 1 and list 2 respectively as our next node. Okay, so this whole logic is to choose which list to pick from next. And the value of next is going to be what we'll be using. So we will have tail dot next equals next equals next, and tail equals tail dot next. And also what we'll say is next dot next is none. Right? That is also important. So we actually have to remove that node, and it won't point to anything if we add it to the tail of the list that we're trying to build. Cool. So now we have to deal with the initialization of our list. And that is as follows. If not head. Well, we'll say head equals tail equals next. Right? So the first node, that's the node that we just extracted. And only when we already have a node in our return list, which is this case, then we append it to the tail and advance the tail one more step. Yes, and so that way we can just safely return tail up here. I think that should be it. Sorry, we return head in the end. I think that should be it. Right. Yes, so here we're taking care of the advancement in here and here, and then we just do the changing of the linking. Cool. So our test cases pass. Let's submit to see if the whole thing works. Ta-da! And the whole thing works. So yeah, that's one way to implement it. There are probably other ways of how you could do that, but I found this the easiest because I was able to reason through every single step, which gave me the confidence that this solution also works. So yeah, give it a shot. It's a nice little problem that forces you to understand list pointers really well.